So it seems like my microphone wasn't working, so I'm going to re-record this starting from question 3. How many three-digit numbers can be formed from the digits 1 through 5? So for these questions, we want to set up kind of our quote-unquote buckets and think about how many choices do we have for every single position. For the first position, we're going to have 5 choices because we have 5 digits to choose from. So we can write a 5 there. And then for the second digit, we're still going to have 5 choices because repetition is allowed, that is implied. And the same goes for the third choice. So in total, when we have all these buckets with different choices per bucket, we multiply the number of choices for each one together, and we're going to be left with 5 cubed. Number 4 is very similar, except now we have different criteria for every position. Our first position is a number, so we're going to have 10 choices there, 0 through 9. But the next 3 are all letters, and so we'll have 26 choices for every single one of them. 26 letters, 26 and 26. And then finally, we'll have 10 choices for the last 3 digits. And so that's going to give us 26 cubed times 10 to the 4th. The fifth one, I'm trying to rank my top 3 favorite books out of 10. And so this one's different. It's not just 10 times 10 times 10, right? Because once I've chosen one book, I'm not going to have it available for my next choice, correct? So I'm going to go one by one. I'm going to try to fill up my number 1 spot first, and then my number 2 spot, and then my number 3 spot. So if I start with my number 1 spot, I'm going to have 10 choices. I can choose any one of my 10 books to rank as number 1. But once I've chosen that, I'm only going to have 9 choices remaining for my number 2 book. And then once I've chosen 1 and 2, I'm only going to have 8 choices remaining for the third one. And so that's why the answer is 720. Next one, for the Homecoming King and Homecoming Queen, I'll have 7 and 10 choices respectively. And so that's why the answer is 70. Pretty straightforward. Number 7 is also very straightforward. 10 choices, 4 choices, then 5 choices. And all the choices are independent, and so we multiply them, and we'll have 200 in total. Number 8 is a little more tricky, so I'll explain that more carefully. Here, I'm looking for 3-digit numbers where the leading digit is non-zero and there is no repetition of digits. Okay, so this is tricky because you actually have to go in the most strategic order. So as I said in class, you're going to want to start by trying to fill the digit that is the most restrictive. Okay, because otherwise you're going to run into problems with different cases, casework. And so we'll start with the one that's most restrictive, which is the first one, right? The leading digit cannot be 0. It can only be between 1 and 9. So that means I'm only going to have 9 choices for the leading digit. Okay, but the other 2 digits, they can be anything. They can be 0 through 9. And so once I've filled the first digit, we ask ourselves, how many choices do I have for the second digit? And the answer is actually not 8, but 9. And the reason is because 0 is now available for us, right? I can choose anything between 0 and 9, except what has already been placed in the first digit. So that leaves me with 9 choices. And so once I've placed those 2, I'm going to have 8 choices for the next one, right? Because I can choose any one of the 10 digits 0 through 9, except the 2 that have already been placed in the first and second positions. So that leaves me with 9 times 9 times 8, which is 648. Right, I'll explain why doing it in reverse would not have been possible. If you had tried to place the last digit first, I would have 10 choices, right? 0 through 9. And then I'll have 9 choices for the second one, because I can choose 0 through 9, except the one that has already been placed. But then we run into issues when it comes to the leading digit. The reason is, it can't be... the reason is because it depends on whether we've already placed down 0 or not. If we've already placed down 0, then actually we are going to have 8 choices. The reason is because we can choose anything between 1 and 9, except the non-zero digit out of these 2, right? Because one of them is 0 and the other one is between 1 and 9, and so we can't choose that one. So that leaves us with 8 choices. However, what if What if neither of these two are 0? What if they're both between 1 and 9? Then in that case, I'm only going to have 7 choices for this one, because I can choose anything between 1 and 9 except the two that have already been placed, which I know are already between 1 and 9. Okay, so that's going to complicate things a lot, and there are still ways you can cleverly account for this if you split it up into different cases, but it's a lot more complicated, obviously. And it's going to be harder work to get to the same answer as above. Hopefully that makes sense.